Hello. Yeah, good morning, everyone. So, I plan today to learn some Godot stuff. I wanna build, go through this official tutorial, and yeah, we can see what the results will be, and how it will work. I hope it will be fun. Yeah, so I think we can start now. So yeah, you first to the game. So I think, yeah, what they're saying, there is a complete version of this project. So I think we need to download this stuff. Yeah, let me grab those files and extract it somewhere. Okay, we have those files. Nice. Okay, content. Yeah, we should start with the setup in our project. So, oh fuck, yeah, my window is too big, way too big. Okay, so this is like new project. Okay, let's do the. I think 3.0 is better. I mean, it sounds better. Okay, here we go, the window. Should have a 2D because this is a 2D game. So yeah, okay, download the file, the archive content, the images, sounds we're using make the game, extract the archive and move the art and phone directories to your project directory. Okay, that's how to find my project directory. Is there okay, I see the icon. Maybe open. Is this will work? No, it's not working. Open in file manager. Oh yeah, this is working now. Okay, so this is the basically empty project that we have right now. So we need to move all this stuff somewhere right here. Hey, is this what they're asking? I mean, yeah. So they have the icon default env dot res. No idea what is that. Okay, approach it like this. The game is designed for portrait mode, so we need to adjust the size of the game window. Click on project settings to open the project settings window, and in the left column open the display window tab. Okay, project. Oh, I see the nice. The art and fonts are here. Okay, project version, and then I think it was window. It was display and window. Don't see actually display window. With also scroll down to the bottom of this section and under the stretch option set. Okay, stretch mode 2D and the aspect keep. Okay, nice. In this project we will have two different scenes: player, mob and HUD. HUD, which we will combine into the game's main scene. How 3 independent scene which we will combine into a game main scene? How that work? In a large project it will be useful to create folders to hold the various scenes and their scripts, but for this relatively small game you can save your scenes and scripts in the project root folder identified by res. And yeah, you can see your project folders in the file system dock in the lower left corner. Yeah, get it. Okay, so what should we do? Creating the player scene. With the project setting in place, we can start working on the player controller character. The first scene will be defined the player object. One of the benefits of creating a separate player scene is that we can test it separately even before we created other parts of the game. Yeah, makes sense. To begin, we need to choose a root node. For the player object, as a general rule, a scene root node should reflect the object desired functionality. What the object is, click the other node button and add area to the node to the scene. It's like this. Should we search for it? Area. Okay, I see area to D. Create. Oh, what's changed? Okay, that's something. Okay, Godot will display a warning icon next to the... Yeah, we have that. You can ignore it for now, we will address it later. With area 2D you can detect objects that overlap or run into the... Okay, so it's like collision. It's like collision in Unity. No, I know something. Okay, change the node name to player by double clicking on it. Okay, so this player. We can add additional nodes to give it more functionality. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the log. Its tooltip says make sure the object children are not selectable. Make sure the options. Okay. Oh, so you basically lock in it, and when someone tries to press on some children node of the player, it will select automatically player. Okay, we can save this scene, but we don't have one. Save the scene, click scene, save. How should I name it? Oh, player. Okay, yeah, that's fine. I love coffee. Okay, sprite animation. Click on the player node and add animated sprite node as a child. Easy. Add child node. Animated sprite. It was just a sprite, right? I like this icon. You don't see it. Well. Cryos. Okay. Sprite frames resource, which is a list animation can be displayed. To create the one, find the frames property in the inspector and click empty to new sprite frames. Click again to open a sprite frames panel. On the left, okay. This is the inspector frames, new sprite frames. And what's next? How? What? Click again to open this. What do you mean? Okay, yeah, got it. Huh. That's interesting. On the left is a list of animations. Click the default and rename it to walk. Then click the new animation button to create a second animation named up. Where's okay, this one. Up. Okay, find the player images in the file system tab. In the art folder, you unzip or drag the 2 images for each animation. How should I do that? Okay. Should I just drag and drop them all? Yeah, I guess it was wrong. Wait a second. Okay, so drag the 2 images for each animation. Yeah, okay, so let's use up now. Up now and walk. And walk now, yeah. Oh. Okay, the player animation is a bit too large for the game window, so we need to scale them down. Click the animated sprite node and set the scale property 0.5. Oh, okay. Is it here? Where is the... Okay. It's still big though. Node 2D, yeah. Finally add a collision shape as a child of player. This will determine the player hitbox. Wait a second. I thought this one is a hitbox. Weird. Is it collision shape 2D? As a child of player, does it remain hitbox or the bounds of the collision area for this character a capsule shape 2D node given the best fit? Okay, so I need to choose the shape. Capsule shape 2D? Is it? Yeah, capsule shape 2D. When you finish it, your player scene should look like this. Yeah, I guess it looks like this. But don't get it, what was anime? It looks like it's working. Why it's bigger? This is weird. Let's just move on. Code in the player. In this lesson we read player movement, animation and set it to detect collisions. To do so we need to add some functionality that we can't get from a built-in code, so we'll add a script click the player node and click attach script button. Okay. Oh.
Computers now have primary control of critical vehicle functions.
Oh, and we can even use C++? Shit. I mean, that's too much for the first session, I would say. Okay, create. Oh, a lot of stuff. Standard export war speed is 400. Size, okay, you just script for yeah, that's fine. Okay, it's actually work like a variable. Where's the script? I mean, hey, what the fuck? Oh, okay, script variables right here. Can we open? Okay. Okay, the ready function is called when. Okay, we need to when we export var, so it's how fast the player will move. Using export keyword on the first variable speed allow us to set its value in the inspector. This can be handy for values that you want to be able to adjust just like in not built-in properties. Click on the player node and you'll see the property now appears in the script variable section in the inspector. Remember, if you change the value here, it will override the value written in the script. This is totally makes sense. The ready function is called when a node enters the scene tree, which is a good time to find the size of the game window. So ready, it's like a start in Unity? Yeah, I guess so. Screen size. Get viewport rect. Viewport rect. And what after size? Now we can use I wonder how it looks like. Get not animated sprite, collision shape. That's actually normal. I mean, you just get in the components from the player, and then input. It's like I think that's also something that is singleton. This is the I don't know, the package or the class that will be used to get some input from the outside. Yeah, and screen size eventually, it's actually the same syntax as in GDScript. Now we can use process function to define what the player will do. Process is called every frame, so it's like update. So we'll use it to update elements in our game, which we expect will change often. For the player, we need to do the following: check for input, move in the given direction, play appropriate animation. Yeah, that's what how the game development works. First, we need to check for input. Is the player pressing a key? For this game, we have 4 direction input to check. Input actions are defined in the project settings under input map. Here you can define custom events and assign different keys, mouse events and other inputs to them. For this game, we will map the arrow keys for the 4 directions. Okay, click the project setting and then open the project setting window and click on the input map tab. Okay. Input map right here. Well, we already have like UI left. Okay, it's UI left. It's not like left. Move. Okay, I see. Move right. And should we do the same for everything, like move left, move up, move down? Yeah, makes sense. Left. Okay, here we go. We have our inputs. Yep. You may, close it. Okay. You can detect whenever a key is pressed using input is action pressed, which return true if it's pressed and false if it isn't. Okay, and we should check for all input stuff. Oh, that's okay. Fan process delta. Oh, nice. This is really useful. It grabs city. Oh shit, no. Okay, I think we coded this part with a movement. Now we need to checking the velocity limit of more than 0. What is length of velocity? I don't get it. I think it's like a left vector, or I don't know, the velocity normalize. Okay, so this want to normalize so it wouldn't be so rapid and I don't know, terrible. Animate sprite play. Yeah, what? Animate that sprite. Stop. Nice. Okay, we will start setting the velocity to 0 by default. The player should not be moving. Then we check. Yeah, so this is how we handle input. So if there is like some event coming from like move right, move left, move down, move up, it will trigger and we will add the velocity like +1, -1, +1, -1. If there is some movement, so we check in is velocity 0 or more than 0, then we play animation, then if not, we stop playing animation. It's pretty, I don't know, pretty obvious. Now we have a movement direction. We can update the player position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to a given range. Add the following to the bottom of the process strip. Okay. So position plus round of velocity delta lamp position x 0. Okay, screen size, so limit. Yeah, looks good. Click the play screen, Command R on F6. Okay, I have F6. Okay, it's working. Nice. So it's like it's like swimming. Nice. Choosing animations. Now that the player can move, we need to change which animation the animated screen is playing based on its direction. We have the walk animation, which shows the player. Okay, it's walking. I thought it's like in the water or something. I thought they're like swimming. And hell no, they're walking actually. Okay, anyway. Is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally. Use the flip property to the left for the left movement. We also have the up function, which should be flipped vertically with to downward movement. Let's place this in the code. Okay. So it's actually a lot of movement here. Velocity. Just like that. Leap we false. Flip H, velocity X. Okay, yeah. No, it's else. Elif, actually. So yeah, in this case we need to flip animation. Yeah, animated sprite. So we trigger it, another animation right here. It's actually like much easier than in Unity, but in the same time, I mean, trigger it from script and this way. I mean, we're still in Unity. You use this animator, like set trigger or set boolean, and then in animator controller you actually assign different stuff. Maybe there is one also for Godot, but this is quite simple. And I don't know, maybe it's even easier. We'll see. Okay. The boolean assignment in the code above are common shorthand for programmer science. We're doing it. Yeah, so it's the same as to assign a boolean, because when y will be more than like 0, this will assign to flip v a true value, and the same here. So this one is actually the same, but it's just easier. You don't need to add like one more if with checks. Yeah, like it will be 1 this line or like 4 of these lines, so it look easier. Okay, moving on. When you're sure the movement is working correctly, add this line to ready, so the player will be hidden when the game starts. Wait, what? Economist key here is to type the names of the animation wrong. The animation names must match. Yeah, makes sense. When you sure the movement is working, okay, let me track. No. Okay, it's going down, it's going up, going right, going left. Yeah, makes sense, works. Yeah, yep. So we need to hide actually the player. Preparing for collisions. We want player to detect when it is hit by an enemy, but we haven't made any enemies yet. That's okay, because we're going to use Godot signal functionality to make it work. And the following add the following at the top of the script after extends area to D. So like here, signal hit. Okay. This defines a custom signal called hit that we will have our player emit, send out when it collides with an enemy. We will use area to D to detect the collisions. Select the player node and click the node tab next to the inspector tab to see the list of signals the player can emit. How the fuck should I do that? Player. Wait, what? Okay, here, nodes. Okay, we have hit. This define a custom called we can emit body entered. Okay, notice our custom hit signal is there as well. Since our enemies are going to be rigid body to D nodes, we want them body entered signal. This signal will be emitted when a body contacts the player. Click connect and the connect signal window appears. We don't need to change any of these settings, so click connect again. Godot will automatically create a function in your player script. Okay, so body entered, right? Yeah, body entered, right. Connect. Okay, then player body entered. There is a green icon indicating that the signal is connected to this function and this code to the function. Okay, so it's like, again, need to hide player. Why should we Okay, player disappears after being hit. Okay, emit signal hit. And collision shape to D set deferred as. I think in this case we just disable the collisions, so this trigger will never be used again. Must be deferred as we won't change physics properties on the physics callback. Okay. Okay. Each time an enemy hits the player, the signal is going to be emitted. We need to disable the player collision. So that's what I said. Like, we need to not something like physics properties and physics callback. It's just to like turn off the collision. I mean, probably the physics property also will be turned off in the same case, but oh, come on. So yeah, so that we don't trigger the hit signal more than once. That's what I said. That's what I said. That's what I said. The last piece is to add a function we can call to reset the player when starting a new game. Okay. What should we add this? Somewhere in the beginning. Funk. Start pose. Position. Show. Vision shape to D, disabled. Okay, I think that's different. With the player working, we'll work on the enemy in the next lesson. Okay, let's test it. Let's test it. Hey, what the fuck? Nobody there. What's the debugger saying? I see the message from the debugger. Error. The argument body is never used in the function. This is intended prefix. It will what? Okay, I hope it should be this way. Because there is no like, I mean, we need to trigger the start, like set the position. We don't actually use this function anywhere. So I think that's should be this way. So yeah, let's just move to the next lesson. Okay, creating the enemy. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edges of the screen, choose a random direction and move in a straight line. We'll create a mob scene which we can then instance to create any number of independent mobs in the game. Note stop, click scene, new scene, scene, new scene, scene, new scene. Okay. And add the following notes. Rigid body to the name mob. Rigid body to the name mob. It's interesting, like why the player was area to the, but the same, like basically I don't know. The enemies is the, it's basically the same object, right? But why it's oh, come on. Frame. Okay, we just need to add those child objects and that's it. Collision shape to D and then visibility notifier. Visibility notifier to the, oh shit, what is this? Don't forget to set children so they can be I love the song. Okay, so don't, yeah, we did that. In the player rigid body property, set gravity scale to 0. This. 0, no gravity. So the mob will not fall downward. In addition, under the collision object section, click the mask. Oh, wait. Collision what? Collision object. Wait, what? It's the shape. What do you mean? I don't fucking get it. What the hell? In additional, under the collision object to D. Where? Okay, I see. But there is no mask. Okay, I see. Fuck. Click the mask property and uncheck the first box. This will ensure the mobs do not collide with each other. So like this? Yeah. Okay. Set up the animation sprite like you did for the player. This time we have 3 animations: fly, swim and walk. There are 2 images for each animation in the art folder. Adjust the speed to 3. Okay, so we need to create actually 3 animations this time. Animation sprite, you will be fly, swim, and walk. Fly. Where is are you flying? Enemy flying. Walk. Okay, they just like 3 frames. I think that's everywhere, right? Okay, set the player property in the object inspector to on. Set the playing property. Where? Where? I see. We'll select one of this animation randomly so that the mob will have some variety. Like the player images, these mob images need to be scaled down. Set the animated sprite scale property to 0.75. Nicely done. Okay. As in the player scene, add the capsule shape for the collision. To align the shape with the image, you need to set rotation degree property to 90 under transform. So it's like capsule sphere. Save the scene. Enemy script. Is it to mob? Yeah, it's to mob. Okay, now let's look at the rest of the script in ready. We play the animation and randomly choose one of the 3 animation types. Okay. Playing through. Frames, get animation names. Nice. So we actually just randomly select. So it's basically, I think it generates random integer and then we just fuck, I don't remember how to call it in English, but it's you just separate, like I think they have a better explanation for this one. Yeah, so yeah, when you need to pick a random number between 0 and 2, select one of the frames from this array in this set start at 0, select a random integer between 0 and n-1. Well, yeah, but is it I know what it's doing, but I don't know how to explain. Yeah, let's there should be explanation. Yeah. Quora. Oh, fuck off. Can you just go Jesus Christ. Yeah, it's the basic operators. Models divides an left-hand operand by the right-hand operand and returns remainder. So, for example, like here you have 5, and the I don't know, this size, the actual size of the animation, we have only 3. So in this case, you will how many times this mob type size fits inside this random variable. It will be like 1, and what's left, the 2 is left, so it will be second animation. And in this case it will be like the last one, because second it's the second. Because arrays, I don't know basically how arrays are starting in GDScript, but in normal programming, array starts from 0. A little bit of programming this morning. Okay, let's move on. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visibility modifier node and add this code. I don't know how to do that. Is it like node visibility modifier node and then screen exited? Yeah, connect. Okay, yeah, looks like Q3. why it's key free though. This completes the mob scene. With the player and the enemy ready, in the next part we'll bring them together into a new scene. Turn out project into a playable game. Okay, yeah, move on. The main game scene. Now it's time to bring everything we did together into a playable game scene. Create a new scene and add a node named main. The reason we're using node instead of node 2D is because this node will be a container for handling game logic. It does not require 2D functionality itself. Click the instance button represented by the chain and select. Whoa. Easy. That's node. Oh no, main. There is no main. Okay, node, but we will have a name. Main name. Fuck no. No. Scene. New scene. Main. Okay, we have a player. I'm so sorry. I almost died. Okay. Click the instant button and select your saved player. Now add the following node as a child of main and name them as shown. Values are in second. Okay, so we need to add timer, which will be mob timer. Okay, let's set timer. Timer, you will be mob timer. Another one will be score timer. And another one will be start timer. And then position to D. Position to D. And it will be what? It will be start position. Set the wait time property for each of the timer node as follows. Okay, mob timer. Okay, score timer 1 and start timer will be 2. In addition, set the one-shot property of start timer zone of the start position node 240 450. Spamming mobs. We need to spam some mobs. Are you ready to spam some mobs? Okay, the main node will be spawning new mobs and we want them to appear at the random location on the edge of the screen. Add path to the node named mob path as a child of main when you select path to D. Fucking hell. No, it's the next. So just path to D. Path to D to the main. Path to D. Path to D. Path to D. And it will be mob path. Okay, when you select when you select Path to D, you'll see some new buttons on the top of the editor. Okay, yeah, we see them. We have them. Select the middle one, add point, and draw the path by clicking to add the points at the corners. Sorry, what? Okay, I think that's the screen actually. Is this the screen size? It should be screen size. Okay, and we should select the middle one. Should we select the middle one? No, it's the different one. Select the, well, yeah, the middle one, and draw the path by clicking the add the points at the corner shown. To have the point snap to the grid, make sure use grid snap and use snap. Oh fuck. This one? Okay, no, they doing it actually like over the whole screen. Like here, here, and then here. So it will be okay. After placing 4 points in the image, click close curve. Close curve. Off, maybe? No? Now close. What you who's fucking hell. I get it, I get it. I almost get it. Here, 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 and here. And then close the curve. Yeah, nicely done. Okay, I think we will just finish this one, and then that's probably all for today. So yeah, after placing the we close the curve. Now that the path is defined, add path follow to D node as a child of mob path. Path follow to D. What? Oh fuck. Okay, I see. Path follow to D. Name it mob spawn location. Hello, new follower. Oh fuck! I don't know how to read that. To Tahrimate. Tahrimate. I'm so sorry if it's wrong, but Tahrimate. Welcome to my almost empty channel. Yeah, hi. Hello, hello. How are you, dude? Yeah, it's probably wrong, but I tried. I really tried. Yeah, welcome to the channel. Unfortunately, I just announced that I will be finishing the stream because I need to go back to actual work. So, but yeah, I hope to see you like next morning. Tomorrow. I will be streaming tomorrow. So yeah, I just need to add this mob spawn location, and yeah. Okay, this node will automatically rotate the follower and follow the path as it moves, so we can use it to select a random position and direction along the path. Okay, I have the same stuff. Nice. Okay. Then that's it for today. Thank you, everyone. Thank you, the crewmate, for the joining our channel. Thanks for the follow. And yeah. See you tomorrow.